I appreciate the opportunity to speak with everyone today. What I want to take you through today is sort of a backgrounder on the big data space. I'm going to talk about some technologies and tools and ways to attack this problem, and talk a lot about customer use cases and stories about how this is used to kind of help drive context around that. As Brian mentioned, I'm with Greenplum. We were acquired by EMC about 2 years ago, known for our MPP, or our multi-parallel processing database. Since that point, we've introduced a number of products. Personally, I'm based in California, so I flew out yesterday, and I appreciate the opportunity to speak with everyone today. So let's just kind of dive into here. I think sort of looking back in time and looking at sort of how we got to the space where we are today, fundamentally applications have been and will continue to be the center of gravity. They are the investment that the enterprise has, and it's the last mile to your customers, to your employees, to all of your end users, and really drive most requirements in any enterprise environment. What's changed, I think, is, as we've looked back in time, these applications created a dedicated infrastructure. So if you rewind 10 years, and you think about when you rolled out ERP or your CRM system, you probably went out and bought a large storage device, potentially an EMC device, a Sun server, you networked that together, potentially a Veritas file system on top of that, and then installed your application. So a very siloed and dedicated infrastructure around applications. Virtualization kicked in, and a lot of these have now been virtualized, but fundamentally, the way we built these applications out were these silos, or these dedicated infrastructures, with the application being kind of the core of that. But things are a little bit different today, and I call this the new normal. Fundamentally, what this chart tries to depict is the reality of today. Every vendor out there, whether they're in medical, government, finance, even the public sector, they're all collecting data. And they're all networking that data. So you and I, we walk around with our cell phones that are producing all sorts of machine-generated data. We fill out applications for insurance. It creates new information. You visit the doctor, et cetera. All of this is being networked. All of this is now interconnected. There are folks out there that are aggregating data. So their entire business is bringing data together and then selling that to enterprises so that they can leverage that for decision making. And then there are the consumers of that data, the buyers, the users, et cetera. More and more, we talk to customers that are bringing in third-party data. So they have their ERP systems that are driving the enterprise data warehouse. But they're enriching that with outside sources. And a very common one is social media. But it extends well beyond that. And we see companies that are transitioning to become data service providers. So folks that have long-term had different use cases are now becoming data service providers. An example of that is the New York Stock Exchange. So this is a company with over 100 years of stock trades, and they're one of the main clearinghouses in the United States. And they've been sort of the middleman between the broker-dealers for a number of years and have collected all of this information. They call it tick data or ticker data. They're now creating a service so that they can take all of this data they've collected and make it available to the hedge funds of the world, the broker-dealers of the world, and becoming less of a clearinghouse and becoming a data-as-a-service business. So that's an example of how they're looking to monetize their assets. They're transitioning their business from service in trades to an actual data provider. And this is, as we see, the new normal. And the data devices, sources, et cetera, a great deal of the volume is coming from machine-generated data. So these are cell phones, these are RFID devices, et cetera. And this is driving the numbers very significantly. It shows up in analyst reports. So this is a report that EMC sponsored. IDC put these numbers together. Their number was 1.8 zettabytes of data, growing 20x in 10 years. So that's a very big number, 35 zettabytes. But to bring it personally, I invite you to think about what your enterprise will look like if your data grows 20x in 10 years. That's 2x every year. That's very significant growth. And as Brian was talking about, we're now fortunate to actually have tools that can start to manage and store and extract value from this information. So it's no longer, the cost of storing this information has changed significantly. The challenge with it, of course, is moving it becomes very painful. So here's a chart that shows you what it looks like to move different data sizes on a 10 gigabit network. And 10 gigabit has been around for a while, but most enterprise standards still run on 1 gigabit. In the data center, they typically deploy 10 gigabit. But what you can see is it takes 10 days to move a petabyte. That's very time consuming. Even in the gigabyte range, 1 second, that makes sense. So in our classic model where we're building dedicated infrastructure and we need to pull 1 gigabyte of data from a storage device into, say, a database or an application, the user will wait 1 second. For a terabyte, it's a different story. In fact, when I was preparing for this speech, one of my colleagues recommended that I stand here for 14 minutes and not say anything to give everybody an idea of what it would be like to move a terabyte, but I figured since you guys would go crazy, that's probably not a good idea. But at any rate, it changes the way that we need to use and leverage data. You can no longer centralize your applications and move the data to the application. Instead, data has become this new center of gravity. So the trends that we're seeing and the way to deal with this volume is to move move the application to the data. And that's fundamentally what these new platforms like Hadoop that was introduced earlier today, MPP databases, a lot of your web scale applications, all of these are about moving a very small executable engine, i.e. a database application, directly to the data rather than moving volumes of data over the big network. So if you think about all of this and it all comes together, fundamentally, it's become known as big data. And I used more of a classic definition than Brian's. I did like Brian's a lot, especially the fourth variable that you brought in. But fundamentally, one way to look at this is when volume, velocity, and variety. So volume is capacity. Velocity is how quickly is it coming at you. Are you doing real-time streaming of stock trades? Are you looking at serving ads in the internet space where you need sub-second responses, et cetera? And variety. Variety is really one of the challenging ones. This is where you see machine-generated data trying to be combined with perhaps your ERP data. And that variety makes it very difficult. And the impact of that is it impacts your accurate and timely decision-making. So one question I get pretty commonly is, how big is big data? Well, for me, it's less about the volume. It's more about the velocity and variety. So we have folks that are under a terabyte, but they're struggling with how quickly the data is coming in. And they're looking at how can we make real-time decisions on streaming data. That's a different problem than a petabyte scale data warehouse. But when you bring these all together, they really account for this whole big data infrastructure and the way to do that. So what I want to talk about is, what does it take to be successful with this? And I'm going to talk about it in really 3 different directions. The first of which is around new applications. So an example of that, I really like this example, is Decide. Is anyone familiar with this application? Okay. Nobody. I invite you to go download this application. This is an excellent use case for big data. The application itself is built to help consumers decide whether or not they should buy. They started with electronics. They've now moved into other different applications. But the idea is if you buy your new cell phone, and this has happened to everybody, you get your brand new cell phone, you're excited about it, you come home, and the next day your provider introduces a new one. Or the next day the price is cut in half. This app is really built to help you solve that problem. And what they're doing is they're collecting a great deal of information. They're collecting pricing, trending information over time. They're scraping blogs and comment forums to learn when is the new iPhone going to come out. And they look back at history, and they bring all of this together into a Hadoop platform and present it up to you in a very simple interface that says, if you're about to go buy, say, a new cell phone or a new dishwasher, take a look at this app and figure out, is the price at the right point given its history? They predict where the pricing is going to go. They predict when the next generation of that particular device is going to come out. So you don't end up buying an iPhone 4 the day before an iPhone 5 comes out. So very good application, a great example. I do encourage you to take a look at that one. It's a very powerful one for the consumer space. And I think it's a great way to sort of showcase how folks are leveraging big data. Another example is more in the business space. So a company called Intra. They are a global logistics supplier for ocean containers. They've been doing this for a number of years. They recently introduced an application called Ocean Metrics. And similar to the New York Stock Exchange story, these folks have been collecting shipping container information from the suppliers as well as the consumers of it, on time, availability of data, et cetera. And they've created a new application called Ocean Metrics, which enables them to share that information with their customers. Now, they're doing this at no cost, so this is not necessarily a revenue stream to the company, but it's a differentiator against some of their competitors out there. They've built this on top of a Greenplum platform, and what they've done is enabled web-based access to all of this ocean information. So if you're a shipper and you're building something and you're perhaps manufacturing in China and you want to ship it here to the UK, you can log onto their application and figure out which shipper is on time, which shipper runs those routes, what do their costs look like over time, and do better decision making based on the information that Intra is delivering. So another example of an application based on a large amount of data that really empowers their consumers to make better decisions and allows them to differentiate themselves in the market versus some of their competitors out there. So that was the first applications. The second is data science, and I think this is a term that is becoming more and more popular. I think definition here is probably in order. I define data science, or maybe Greenplum defines it as the art of mathematically sophisticated data engineers delivering insights from data into business decisions and systems. So a bit of a tongue twister there, but if you break it down and you think of the art of mathematically sophisticated data engineers, that right there is a very unique skill set. So statistics, mathematically based, but data engineers. And to Brian's point earlier around Hadoop, it is a programmable thing. It does take the extraction of the oil. It takes the refinement of that. And data science is the refinement side of that. And these folks are very powerful within the organization. They typically align with the line of business, so they understand the issues that the organization is facing. They have a very good understanding of the data itself. And they're the ones building these algorithms and building these predictive models that allow all of us to make better decisions, data-driven decisions. It is a little bit different than what we've been doing for a number of years. So if you think about your enterprise data warehouse, you think about your BI tools, doing really standard reporting on what's happened. What did my finance look like last year? What does sales look like year over year? It's really a backward-looking or a rear-view mirror-looking way at the data. But data science is more predictive in nature. So it's the what-ifs. It's the, if we raise prices, what will happen? What are our competitors going to do? What's going to happen to the cost of a cell phone over the next few days? This is where data science comes in. It's in that forward-looking, predictive enterprise type of way of looking at data. A couple examples. Anyone familiar with Kaggle? A few hands going up. Very interesting organization, a partner of Greenplum. They offer fundamentally contests. So as an enterprise or as an end user, you can put your information out there. And I took a screenshot of their homepage. You can see they have 4 contests going on. So Allstate, big insurance company in the United States, they're looking to predict which customers are going to stay with them. And they, in effect, put a data set out there. Anyone in the world can participate. It's a contest. It runs for a set number of time. And there's a prize. Probably a little bit difficult for you to read. One that is interesting is this Heritage Health Prize. This is a $3 million prize. So it's funded by the US government. And they're looking at ways to identify who's going to be in the hospital in the next year. And if they can better predict who's likely to end up in the hospital, they can save healthcare costs. So they've put a $3 million prize on that. It runs for about 6 months and is a good example of ways to leverage data science if perhaps you don't have a team internally. Right? A lot of folks don't have these artists in mathematics that understand data science. So Kaggle is a very interesting organization. We run a couple contests through EMC where we've sponsored different actually healthcare-based studies, and the results are very interesting. So I encourage you to take a look at Kaggle. It's a very unique way of looking at data science. Another example I'd like to talk about is CareCore National. So CareCore is a inspections-based healthcare company. So fundamentally what they do is they create treatment pathways. So if you end up going into the hospital for a broken arm, for example, they've defined the pathway that the doctor must follow in order for the claim to be paid. So healthcare in America, as you probably hear, is challenging and an interesting space. But fundamentally, they work in this space to help doctors better treat their customers. And they also work with insurance companies to better understand payments. And what they looked at was a change in regulation. So the US government decided that they're no longer going to pay for hospital-induced infections. So if I go into the hospital and I don't have an infection, but within my treatment period I do get an infection, the insurance companies and the government's no longer going to pay for it. One study had it at a $56 billion a year issue, with about 110,000 lives being taken from hospital-based infections. So solving this is very important. So they worked, CareCore worked with Greenplum's own data science team. We collaborated on 10 years of patient history based on insurance records, and we looked at contributing factors to infection in the hospital. The end result after about a 6-week study was we found a 1% better increase in ways of identifying those patients. So not a huge number, 1%, but it is if you aggregate it over that 56 billion and 110,000 lives per year. So a way that our data science team is using advanced algorithms to really help people's lives and save money for a large organization. So an example around data science. So the third piece, I talked about applications and I talked about data science. I think the third piece is the platform. And the platforms, there are many examples out there. The first I would like to bring up is MPP, or MPP databases. And this is fundamentally what Greenplum is known for. And I think, as stated in the opening, these have been around for a long time. But they do change the way you look at data. If you compare it to an enterprise data warehouse, they run anywhere from 10 to 100 times faster at about 1/10 the cost. And the value here is what they've done, or what we've done, is taken that database structure and distributed it on many commodity servers. All of those servers work in parallel to deliver faster answers, but because it's this commodity infrastructure and software-based pricing, it changes the economics of extracting data. An example of that is ClickFox. ClickFox is a company that aggregates everything from telephone calls to help center chat to emails to look across all of your business to better serve end-user customers. They were a long-time Oracle customer. They moved over to Oracle and, as you can see, have much better performance. So a big part of that is performance in MPP databases. But I think that what's changed is just as the MPP database was about 1/10 of the cost of your enterprise data warehouse, Hadoop is yet another lockstep 1/10 cost reduction. So we've gone from 100x to 10x to 1x here in the Hadoop space. So it's changing the economics of the way people are looking at saving data, accessing data, and getting value from the data. One of the challenges with Hadoop is some of the out-of-the-box functionality. One could argue that an MPP database has very similar functionality to what you'd expect in your enterprise data warehouse. Hadoop is a bit of a different animal. It's really a programmatic, I define Hadoop as a programmatic batch processing at scale. And I think the important word is programmatic. It's batch. So programmatic implies there is no strong SQL interface. There's not a lot of applications based on it. A lot of it is programmatic. You actually need developers to come in and write MapReduce programs or leverage the tools on top of that have all sorts of interesting names like Pig and Hive and Zookeeper, et cetera. But it's also very batch in nature. I think there's a lot of effort to bring it more towards real-time and streaming data. But fundamentally, it's a big batch processing engine. So it's designed to scale out very large. It's designed to be very affordable and very economic. But it does require a little bit of programming, and you do need to understand this is a batch system. This is not going to replace your ERP system today. We had a customer that leveraged Hadoop for transformations. So they had a very large system. I won't name the vendor. They had a very large system that they were looking at doing a refresh of their annual maintenance, and it was a rather large number. And they took a very close look at how they were using that system, and they realized about 60% of that overall capacity was used for data transformations. So they were bringing in data, they were transforming it, et cetera. And they realized with Hadoop, they could basically cover all of that cost. I'm sorry, they cover the costs of the maintenance by bringing in a Hadoop system. So they changed the economics of how they go about that. So a very good use case of Hadoop. The alternate example is a company that was dead set to use Hadoop. They had a problem that could be solved with a database instantaneously, but instead they were dead set on Hadoop, and they actually threw a very primitive tool at the way they went about it. And the end result was they spent millions of dollars in consulting to solve a problem they could have done out of the box for about a couple $100,000 on a database system. So the point here is there really isn't one tool that solves all of this. There is no magic box, as Brian said. It takes more than one tool to really deal with this whole big data infrastructure. The way we present it is it really requires a unified platform. At the base of that is structured and unstructured data, so maybe Hadoop, MPP database, but processing elements aligned around the data and the cost and the value of that data. The second piece, which is where we're investing very heavily, is this tools layer, which is the ability to really access that. Rich SQL, I mean, how many years have we been teaching SQL in our enterprise? 20 plus years of SQL expertise. Bringing that into these new platforms is critical. Making the applications run very clean is critical. It needs to be a point where the end user has no idea where his data lives, but can access it using the tool of choice. And then the third piece, very important piece in my opinion, is people. So bringing skill sets into your organization, using your existing organizational skill sets, helping them work together collaboratively, more efficiently, and better use of data is the third piece that really is required in this overall platform. An example of that is ComScore. Very large internet provider. They do 32.5 billion interactions a day, so they're importing 32.5 billion records into a Hadoop system. Leveraging an infrastructure like I just described, they created 5 new products in the first week. So very efficient, very interesting way of driving that data. At Greenplum, we talk about this predictive enterprise, which is really the confluence of all of these things. It's data science, it's applications, and it's the platform. And we'd love to talk to you about all of these different areas that we can explore and help drive information. To close, I just want to talk about kind of the top 3 steps and the ways to really get started as an organization, right? So top 3 steps on your journey. The first step is about investment. And we encourage you to invest primarily in people, think about new technologies, and fundamentally in your own commitment to this space. This is a new journey. This is not, let's build another ERP system. This is about bringing in all of your people, investing in them, investing in the technology, and a commitment to really drive value out of all this information. The second recommendation is have a strategy, right? Our data science team talks about modeling less and iterating more. So as you grind through these massive amounts of data, it's about iteration, and it's about collaboration. So it's less about, let's not spend 2 years building a data model and then extracting value out of it. Let's get the data in the system quickly. Let's iterate through it. Let's find the right information and then model it up. So a very different approach than, say, your classic enterprise data warehouse way of approaching it. And the third piece is putting all your data to work, right? We've been all storing this. We've been collecting this. Outside third-party information is available. Bring it all together, put it to work, build a successful story around it, and enable your enterprise to drive more value. With that, I encourage you to get started today. One final message is we are doing a very large project at EMC. It's called the Human Face of Big Data. It launched a few days ago. We encourage you to get involved. You can see on the website, it's basically we're going to have humans all over the world sort of track their day and talk about their data and sort of prove out that slide I had earlier about the new normal around big data. With that, I thank you for your time and attention.